A common type of integral you may have to do is a trigonometric integral. That would be an integral of sine theta to the nth power times cosine theta to the nth power d theta, where m and n are typically whole numbers. There are two cases that this falls into. The first case would be if both m and n are even, so m and n even. That includes 0, but also 2, 4, etc. And then we would use the reduction formulas. So we would use sine squared theta equals 1 minus cosine 2 theta over 2. And we would use cosine squared theta, or we might use it, 1 plus cosine 2 theta over 2. Okay, it's best to work in example. So one integral that is very important is the integral from 0 to 2 pi of cosine squared theta d theta. Cosine squared is always positive, so when you integrate cosine squared, you're always going to have a positive result. So in order to do this, we can use the reduction formula for cosine squared. So that becomes, we have a 1/2 then, the integral from 0 to 2 pi of 1 plus cosine 2 theta d theta, just directly applying the reduction formula. And then this one we can do, you can do a simple substitution or you can do it in your head. I think this one's easy enough to do in your head. So that becomes 1/2. Then we have the integral of 1 d theta, which will be theta, plus the integral of cosine 2 theta d theta. So the derivative of sine 2 theta is 2 times cosine 2 theta. So we have to have plus 1/2 times sine 2 theta to catch cosine 2 theta. So the derivative of this will be cosine 2 theta. And that's evaluated between 0 and 2 pi. It's a definite integral. If you look at sine of 2 times 2 pi, that's sine of 4 pi. That's 0. If you look at sine of 0, that's also 0. So this second term here doesn't contribute. So the only contribution is from the theta term. The 0 on the bottom also doesn't contribute. So it's just theta at 2 pi divided by 2. So 2 pi divided by 2 is just pi. Okay. So that's the case where m and n are even positive integers. What is the case? We can also have one of them odd. So let's say m or n are odd integers. Then how would we do that? So it's just one of them. One of them can be even and the other one odd. Let's look at, in this case, before we look at an example, let's see what we need to use. In this case, we're going to use the Pythagorean theorem. So we're going to make use of sine squared theta plus cosine squared theta equals 1. So let's see how that will play out in an example. We can look at the integral from 0 to pi over 2 of cosine cubed theta d theta. Okay. The cosine function is positive between theta equals 0 and pi over 2. So I constructed this example so the integrand is always positive. I don't want the answer to be obviously 0. So in order to use the Pythagorean theorem to integrate this, we need to write this as the integral from 0 to pi over 2 cosine squared theta times cosine theta d theta. Then we can replace cosine squared theta using the Pythagorean theorem, and you'll see that we have a good substitution we can do at that point. So let's replace this. So let me move over here. So this is the integral from 0 to pi over 2. So cosine squared theta becomes 1 minus sine squared theta, and then times cosine theta d theta. And now we look for a substitution. If we let u equals sine theta, then we have du equals cosine theta d theta. So that's a very nice substitution. We can let u equals sine theta. So then du becomes cosine theta d theta, which is in the integral. So we have the integral then is the integral of 1 minus u squared. And then we have our du. Okay, we can change the limits, so we might as well change the limits. So when theta equals 0, u equals 0. And when theta equals pi over 2, u equals 1. We saw this limit change before. This is a polynomial. This is relatively easy to integrate. So the integral of 1 becomes u. The integral of u squared, so we have a minus, becomes u cubed over 3. The limits are between 0 and 1. The lower limit will be 0, 0 minus 0. So it's just the upper limit. So that becomes 1 minus a third. And that becomes 2/3. So we were able to do this rather complicated integral of cosine cubed theta d theta. So let me summarize. Frequently you might frequently encounter an integral of the form sine to the nth power of theta times cosine to the nth power of theta d theta. There are two methods of integrating this depending on what these integers are. If both of these integers are even, then you can make use of the reduction formula. Here I do a simple case of integrating cosine squared theta d theta. If one of these integers is odd, then you can make use of the Pythagorean theorem, which then permits you to do a substitution. If this gets very, very complicated with large values of m and n, you would use software to integrate it. So basically, you should know how to do the very simple cases. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.